This video is on the summer work packet, Kinematics section, specifically the defining motion section. There are a lot of new terms that you need to understand in order to do well in this section. The first term that we're going to talk about is distance. This is the scalar quantity associated with the change in position of an object. So when we're talking distance, we're talking about how far has it changed its position during its motion. Displacement is the vector quantity. Associated with the change in position of an object. So a vector means that it's not just how much, it's also in what direction. So let's do an example. I start here and I walk 10 meters to the east and 10 meters north. If I wanted to find my distance traveled, this is just asking how far did you walk? So how far did you walk? How many meters did your feet travel? Well, first you traveled 10 meters, and then you traveled 10 meters. 10 plus 10 is 20. Displacement is not so much how far you moved, it's how far from point A to point B. So how far did we move from this point to this point? Well, my distance traveled was 10, but there were other ways to get there. I could have cut the corner. I could have just walked straight across. To find that distance, I have a right triangle. To find the hypotenuse, knowing the two sides, I would use the Pythagorean theorem and do the square root of 10 squared plus 10 squared equals 14.1 meters. Now displacement is a vector. I know how far from the beginning I am, but I don't know in what direction. So I need to say in what direction. I need to figure out what this angle is. Well, the angle there for a triangle that has a side 10 meters and 10 meters would be 45 degrees. 45 degrees from where? This is where we're going to talk really briefly about bearings. This one is north of east. 45 degrees north of east. We always need a reference. We are north from east, so we're going to start east. Here's where I am. There's my line east. Now I need to go north from it until I get up here. That angle there is my 45. If you don't really understand what I'm talking about with bearings, it's okay. We're going to get into two-dimensional kinematics after we get back from summer break. But I just wanted to do a real quick refresher for those of you who may have already had pre-calc, how we talk about bearings. Some other concepts that we need to talk about is speed. This is the scalar quantity for how fast an object moves. Speed equals distance over time. Or velocity. Velocity is the vector quantity for how fast an object moves. Velocity is equal to displacement over time. The last term that we're going to introduce is acceleration. This is the rate of change of velocity. Because velocity is a vector, this is also a vector. Acceleration equals the change in velocity over time. If we're talking one-dimensional motion, that is motion in a straight line, either forwards or backwards. So one-dimensional motion is walking forward and walking back. You're not going left, you're not going right, you're just going in one direction. We're going to use positive and negative to show that direction. For our vectors of displacement, which we typically use delta x to represent, velocity, which we're going to use the v to represent, and acceleration, which we're going to use a to represent. Most of the time, positive is going to mean forward and negative is going to mean backwards. There are 4 scenarios that I want to talk briefly about before I conclude this little video. If the object is moving forwards and speeding up, we're going to say that the velocity is positive. Again, moving forward, velocity is going to be positive. If it is speeding up, that means that velocity is increasing. So our delta V way up here, our delta V is positive as well. So A is positive. If the object is moving forwards and slowing down, I'm going to say the velocity is positive, but the acceleration is negative. Because this delta V, the final minus the initial, the final is smaller than the initial because we're slowing down, so it's going to be a negative acceleration. Those 2 scenarios tend to be easy for students to remember. The other 2 scenarios are harder. This is for when an object is moving backwards and speeding up, or the object is moving backwards and slowing down. If the object is moving backwards and speeding up, the velocity is negative. It's moving backwards. But because it's speeding up just means that the magnitude of the velocity is increasing. That means our number is getting more negative. So if we think about our final minus initial, V final minus V initial, my V final would be something like negative 100 minus my initial of negative 10. That would be me speeding up negatively. That's still going to give me a negative acceleration. On the other hand, if V is negative, but if I'm moving backwards, my V is negative, but I'm slowing down, V final minus V initial, the final, let's say my initial is negative 10. If I'm slowing down, that means my value is going to be something smaller than negative 10, or something closer to 0 than negative 10, something like negative 2. Negative 2 minus negative 10, that becomes positive. I get a positive acceleration. The pattern to note is that forward, the direction forward, means positive velocity. The direction backwards means negative velocity. Speeding up, however, means that our 2 signs match. Slowing down means that our 2 signs are opposite. When your acceleration and your velocity are in opposite directions, you slow down. When the acceleration and velocity are in the same direction, you speed up. And that's going to do it for this section on defining motion.